Basically going to do the same thing for 9.2. We're going to find confidence intervals and sample sizes. To do that, we're going to use StatCrunch. But this time we're going to go stat, tstat, one sample with summary. We're going to get the sample mean. Sample mean is 105, standard deviation is 10. And sample size for this first part is 25. And we want confidence interval at 98%. So we're going to 1 decimal, 100, and 110. And now we'll change the sample size to 13. And we get 97.6 and 112.4. All right. And there's going to be some questions in this section where you might want to jot down this right here. This is a little diagram I give my students in class. And it just says as sample size goes up, confidence goes up. As sample size goes up, margin of error goes down. And as confidence goes up, margin of error goes up. And if you swap any of these errors, so for example, if you said confidence here goes down, then you would swap the direction of this arrow as well. So margin of error would go down. All right, so how does decreasing the sample size affect margin of error? So decreasing sample size, right, would increase margin of error. So let's go back over here. So decreasing sample size, if this goes down, we're going to change this goes up. So decreasing sample size increases margin of error. So as sample size decreases, margin of error increases. So that would be B. All right. So let's change our confidence over here. So we're going to 80%. And sample size is 25. So this time we get 102.4 and 107.6. All right, and this time, how does decreasing level of confidence affect margin of error? So decreasing level of confidence makes margin of error go down. As percent confidence decreases, the margin of error goes down. And if that goes down, that means the interval decreases as well. Okay, so margin of error, you want to think margin of error, wide interval. Small margin of error, narrow interval. Okay, so do another example. So just go back and change the sample mean. It's 18.8. Standard deviation, 4.9. Sample size, 35. And we get 2 decimals, 17.72 and 19.88. All right, and then we'll change a couple things here. So sample size now goes to 51. Let's make sure we got our confidence. I think we need to go back. This is 95% confident. So let's go back here and change this to 95 and change our sample size to 35. I don't think I changed that. So we get, jot this down, 17.12 and 20.48. 12, 20.48. All right, so now again, check your confidence level, 95. So 95. All right, everything mean standard deviation stays the same, so we're going to go now to 51 sample size. And we're going to get 17.42 and 20.18. 42, 20.18. How does increasing sample size affect margin of error? So increasing sample size makes margin of error go down. Margin of error decreases. So again, I'm just using increasing sample size here makes margin of error go down. I'm just using this little chart that I give my students. So let's do another confidence interval here. So this time we're going 99%. 99%. Sample size is 35. Okay, so we just change confidence this time. And we get 16.96 and 20.64. And 20.64. Okay, an increasing level of confidence affects the size of the margin of error. So increasing confidence means margin of error goes up. So margin of error increases. And let's see, we've got 2 decimals. Check that real quick again. Oh, didn't change our sample size. Again, folks, change your sample size here. Okay, 99% confident, mean standard deviation, and sample size is 35. So we get 16.54 and 21.06. $16.54 and 21.06. There we go. So be careful changing the sample size. All right, so do a couple more here. So this time dealing with drive-through times for fast food restaurant, 90% confidence interval. And the results from examining 608 customers, sample size 608, found that the lower bound is 158. Oh, well, if they already give you a confidence interval here, so this is just interpretation. So one can be blank percent confident, which is 90% confident. The mean drive-through service time of this fast food chain is between here and here. And no, that's probability. Nope. And no. So it has to be this one here. So 90. And then lower bound, 158.6 and 162.2. All right, so now we'll do researcher wishes to estimate the average BAC, which is blood alcohol concentration, for drivers involved in fatal accidents who are found to have positive BAC. That just means that they were positively drinking and they had a fatal accident. So he randomly selects 82 drivers in 2009 and determines the mean or average is this, standard deviation this, construct a 90% confidence interval. So we've got 90%, we've got mean 0.16, standard deviation 0.07, and sample size is 82. Sample mean, 0.16. Standard deviation, 0.07. Sample size is 82. And we want 90%. So we're going 3 decimal places, which will be 147 and 173. Okay, so again, let's get interpretation. The researcher is 9% confident. The population mean is in the confidence interval for the drivers found in fatal accidents who have. Okay, so this is the one we want because this is 10%, and this down here says is not in the confidence interval. So this is the one we want. 147 and 173. All right. So now all areas of the country use 0.09 as legal intoxication level. Is it possible that the mean BAC of all drivers involved in fatal accidents who are found to have positive BAC is less than the legal intoxication level? Well, the legal intoxication level would most likely be more than 0.09 if they were involved in a fatal accident. So I'm going to go yes, it's possible the mean BAC is less than 0.09, but it is not likely. Okay, that's going to be, because it is possible. I mean, anytime you're doing statistics and probability, you're estimating. Okay, so, and that's all that they're asking, right? Is it possible? So I would say, yes, it is possible, but it's not likely. Okay, so this time we've got time spent eating and drinking. Suppose 1,005 people, 15 age and older. The mean amount of time spent eating or drinking is 1.82 hours. Success. So let's jot this down. Mean is 1.82. Standard deviation 6.7. Sample size 1,005. And we want 99% confidence interval. So 1.82. Standard deviation 6.7. 1,005. And we want 99. So we're going 3 decimal places here. 765 and 875. So we want 99% confident. The mean amount of time spent eating or drinking per day is here and here. So 1.765 all the way up to 1.875. All right, could the interval be used to estimate the mean amount of time a 9-year-old spends eating or drinking? Well, this data here is for 15-year-olds, so no, the interval is about individual time spent. No, the interval is about people age 15 or older. The mean amount of time eating or drinking for 9-year-olds may be different. So that's kind of the most logical one on that one. Okay, now when you get to with data, I'll show you how to do that. So just open up the data, and we're going to go tstat one sample with data. So when you have data, just do with data, select here, and then you can leave it at 95. They're wanting a point estimate, and the point estimate is going to be the sample mean. That's all it's going to be. So 2 decimals, that's 5.04. 5.04. Now, here's where they give you 95. It just so happens we left it at 95, right? We left this at 95. So if it changes, just be sure to go back and change that. So now we've got, what are we doing? 2 decimals. So we got 4.74 and 5.34. So let's go back over here. And we're talking about the pH of rain. So there is and again, always choose the one that has confidence. Okay. So 4.74 and 5.34. Now we'll change it to 99% confident. So just change it to 99. And we do, this time, 4.61 and 5.46. .61, 5.46. Okay, what happens to the interval as the level of confidence is changed? And here you can just look as the level of confidence went from 95 up to 99. And as we're changing, remember, as we're changing the level of confidence, right? As level of confidence goes up, the margin of error goes up, which makes the width go up. So as level of confidence increases, the width of the interval increases. This makes sense since the margin of error, right? Because that's the width of the interval is connected with the margin of error. So the margin of error would increase as well. So again, for questions like this, the best thing is just to use these little arrows here. Okay, so we've got another one with data. So tstat one sample with data. Select your variable, and we want the sample mean, so we'll just leave that at 95 at this point. Sample mean is 2.4. That's your point estimate. 2.4. Standard deviation. Now it doesn't give you standard deviation, but we can just do what we did in chapter 3. Just go back and find standard deviation. Standard deviation to 2 decimals is 1.19. And then 90% confidence interval. So tstat one sample with data, doing 90% confidence. So just change that to 90%. And we're going 2, so 1.78 and 3.02. 3.02. Okay, another confidence interval. This time the amount of radon gas in a tune that's not well ventilated. So we got sample mean here, standard deviation here, and sample size of 12. So let's go over, plug in the data. Let's see, did we have another one open here? Yeah, let's go back to using that one. So we've got mean is 3513. Standard deviation 1159. Sample size 12. And we want 95% confidence. So we're doing to the nearest integer, so we'll just round to the nearest whole number, which is 2777. 2777. and 4249. 4249. 2777, 4249, 4249, and then the true mean is what we're wanting. We are 95% confident. The true mean level of radon exposure in tombs in the region is between here and here. So again, 2777 and 4249. Okay, so again, got some more data here. So we'll just do point estimate. So the target parameter for 9.2 is always the estimating the true population mean. And we want to get the data open. And we're going to go stat, pstat, one sample with data. We have data. Select the variable, and then just leave that at 95. Well, it does ask 95 here, and the point estimate again is going to be population, or excuse me, it's going to be sample mean. 2 decimals is 8957. And now we'll get our confidence interval. To 1 decimal is 78.7 and 104. All right, and one can be 95% confident that the true mean lies within the interval above. That's how you want to interpret these things. Now we'll do confidence, we'll do sample size questions, okay? So sample size, I'll show you how to do that for 9.2. You're going to do stat, very similar, pstat, one sample, width, and sample size. Confidence level is 99. Standard deviation is 19.5. And you take your margin of error and just double that. So margin of error within 2 points, we'll double that to 4. Now don't convert to percent because we're talking average here. Students commonly do that. So sample size is 635. Now we'll change to 90% confident. Go back and change your margin of error. Get 260. All right. So how does a decrease in confidence affect sample size? So go back and look at your arrows. Decrease in confidence makes sample size go down. So decreasing confidence level decreases the sample size. Again, that's just looking at your arrows. Another sample size question. This time we've got 90%. And we want 17.7, standard deviation, sample mean. Let's see here, how many subjects you need? Oh, sorry, wrong spot. Stat, t-stat, one sample with sample size. So we've got 17.7, standard deviation. Confidence level, 90%. And margin of error, so margin of error within 6 books, we're just going to double that to 12. Remember, always double the margin of error. So we get 26 people we would need to sample in that case. All right, mean number of books within 3 books. So we double the margin of error to 6, and 90%, everything else stays the same. So the only thing we change, margin of error. We'll go from 3 to 6, and we get 117. 3 books. I did double that to 6. 90% confident. Standard deviation. Oh, excuse me. Standard deviation is 17.7. 17.7. So that's 97. Now, there are some leeway with the sample size questions. As you notice, we still got the same answer here. But you should have changed the 17.7 as the new standard deviation. Okay, be sure to change that. Okay, and doubling the required accuracy, basically going from 6 books, which is wide, down to 3 books, which is narrow, which makes your interval more accurate. Our sample size went from 26 up to 97, which is almost by a factor of 4. So the sampling size quadruples. So doubling required accuracy, nearly quadruple sample size. So we'll do one more here, going back to margin of error of 6. So go back to 6 double is 12, and then 17.7, and then change your confidence to 99, and that goes up to 62. So increasing level of confidence affects sample size. So increasing level of confidence goes up. That means sample size goes up. So increasing level of confidence increases sample size. It has to be here and here. So for a fixed margin of error, greater confidence can be achieved with a larger sample. And that kind of makes common sense, right? If you're more confident, then you have more people in your sample. So that would be C. All right, and the last one here, we've got an IQ test is designed so that the mean is 100, standard deviation 19. Find the sample size required to estimate the mean IQ score of statistics students such that it can be said 90% confidence the sample mean is within 7 IQ points. Assume standard deviation is 19. So sample size question again. And we're doing 90% confident. Standard deviation is 19. And we wanted within 7 IQ points, so double that to 14, margin of error. And we get 22 students. Would it be reasonable to sample 22 students? Yeah, it's reasonable. So it's a fairly small number. So we can say that. Okay, so that's 9.2, and I'll see you on the next video.